Hello and welcome to chapter 4.2. In this chapter we are going back to the future and change the history of a branch. Are you ready? So let's fly! Lisa's first task in this part is to create a new branch, add a new test, and then create a commit. Next up, she shall fix the test because she introduced a bug in the first run, and amend the fix to the previous commit. As you know by now, a commit points to a snapshot of files in the repository and contains a message, a hash, a timestamp of the creation, and the author email address. The history of a branch is made up by its commits and is called the commit history. Let's say we have just made a commit E with a README file in it on our MyNewBranch, and notice that we have forgotten to add the index.html file to it. I know we just could simply add a new commit, but we don't want to. How can we still add this file to the commit E? Well, actually, we can't. But rewriting the commit history of the MyNewBranch is possible in order to have the index.html file in the same commit as the README file. One way of doing that is to amend the index.html file to commit E. So first we have to add the index.html file to the staging area and then commit with commit -- amend. With that, the existing commit E is unrolled and our Git default text editor with the previous commit message of commit E is opened. Once we have edited, saved and closed this commit message, the index.html file from the staging area and the README file from commit E are added to a new commit E apostrophe. But why do we have a commit E with an apostrophe and not a completely new commit F, for example? Well, this is because the only thing which has changed in this commit is its hash value and the commit message. The timestamp of creation and the author stay the same. It is important to notice here that when we use -- amend, we rewrite the Git history of a branch. Most commonly we do this on our own private feature or bug fix branches and not on the main master branch where everyone else is working on or taking their own branches off. Okay, let's help Lisa with her first task of this chapter. We will create a new branch and call that branch test 5 Lisa-amend. Now on this feature branch here we will create a fifth test in the Bowling Game 2 test class, and we name that test Lisa test 5, and now we pretend that we actually implement a test here but with a bug in it. Let's say bug. Great, then we hit git status to see where we are. Yes, we have some modified changes in the working directory which have to be staged, and then we want to create a commit. So let's do that in one go. Git commit -am. So what will this commit do? This commit will add a fifth test. Great. Then quickly check that, git log. Yes, add a fifth test. It's the latest commit. Perfect. And now we are in the situation where we actually want to fix that Lisa test 5, but we don't want to create a new commit. Now we want to amend just our new changes. So let's say we fix that bug here. Good. We hit git status. And we have modified the Bowling Game 2 test class, and now we have to add these changes to the staging area. Git add, and then dot. Perfect. Git status again. And now we will do a git commit -- amend, and Git will open up now our default text editor, so in our case it's still Visual Studio Code, and we will use just the same commit message as before, so we can close that one. And now when we check with git log, we can see that we still have this one single new commit on this branch, but now with the fix already done in this Lisa test 5. So we have amended the bug fix which we did, so we removed the comment in this Lisa test 5 and amended it to the previous commit, add a 5th test. Lisa's second task in this chapter is to create 2 additional tests on the same branch from before, and each of these tests in a separate commit. Then she shall clean up the branch by squashing all the commits into a single one. But first, some theory. Another way of changing the history of a branch is by using the interactive mode of rebase. Other Git commands also know an interactive mode, but the one of rebase is something you will probably using more often in the future, as it offers to change the history of a branch as much as you like. Let's take the example from before and expand it a bit. Let's say we have added a README file with commit E and an index file with commit F. We suddenly notice that we have forgotten to add some important documentation to our README file and add an extra commit G for that. When we now have a look at the commit history of the MyNew branch, it looks like this. The latest commit is on top here. Doesn't look super clean, right? The one thing we want to fix about these 3 commits is to meld the add more text to the README commit G into the add README commit E. With that we will have then 2 proper commits on the MyNew branch, which results in a nice and shiny commit history. Let's give it a try. To change the 3 commits on the MyNew branch, we want to rebase them onto their parent commit C. That is the commit just before all these 3. We can reference commit C either directly by its commit hash by writing git rebase-i and then followed by the hash value, or by writing git rebase-i head -3. Head -3 means the 3rd commit from the commit where the head is pointing to. Once we execute that command, what we then get in the text editor is something like this here. As usual, Git explains quite nicely what we can do now. The commands which you will probably be using the most in the future from here are pick, reword, squash and fixup. Now pause the video for a moment and think what we have to do in order to get the commit history we want. And did you find what we are looking for? Obviously, we want to have something like this here. We want to fix up the add more text to the README. But wait, are we done yet? Not exactly. We missed something. Because fixup in this constellation will meld the add more text to the README into the commit with the add index commit. That's not exactly what we want. Another powerful move we can do with the interactive mode here is to change the order of the commits. We can actually reorder these lines here. Well then, let's do this. This will do the magic trick for us. It will meld the add more text to the README commit with the add README commit, and thereby discard the commit message add more text to the README. We now can close the text editor and Git will do the rest for us. When we hit git log --one line again, Git shows us the new commit history with 2 new commits on the MyNew branch. In our model, it looks like this. With commit E' and commit F apostrophe, we have rewritten and rebased the commit history of the mynewBranch onto commit C. We now have a clean commit history on our branch. You might ask yourself what happened to commits E, F, and G. Well, these commits still exist. They just aren't referenced by any branch pointer anymore. Git doesn't delete any commits, only in some very rare cases. For example, dangling commits which aren't referenced by any other commits. So with Rebase Interactive, you can change the history much more substantially than compared to amending. One important thing to notice when rewriting the history with amending and Rebase Interactive is that in both cases new commits with new hashes are created, but the timestamp of creation and the author are taken from the original commits. That is why I have marked these commits with an apostrophe. Okay, let's help Lisa with her second task. We are on the feature test 5 Lisa amend branch, and now we will just add a 6th test. We will call that test Lisa test 6. Then we will quickly check that again. That's kind of always good to check that. Then we will add and commit again in one go. Commit -am and add a 6th test. Exactly. Perfect. Let's verify that. Git log. Yes, there we are. Add a 5th test and add a 6th test. Yeah. And now we do a 3rd commit on this branch by adding a 7th test to it. Lisa text test 7. Very good. And then we will do a git commit -am and we add a 7th test. Perfect. Check that one. Git log. Yeah, there we are. So to add a 5th, add a 6th, and a 7th test. Now what we want to do is actually to squash these 3 commits into a single commit so that it looks a little bit nicer and shinier, our commit history on that branch. So let's do a git rebase -I for interactive and then use the head pointer here and the ~3 to actually squash these 3 commits together. Then the Git will open up our Git default text editor, Visual Studio Code. And what we now want to do, we want to squash the add 7 test and the add 6 test into the add a 5th test. So combine all these 3 in just one. And for that, we will use git fixup. So it's like a squash, but discard the commits log message. So F and F. Perfect. And then we will also, what we're also going to do is to reword our commit message of the first commit here. So we put an R in front of it. And then save that, close that. Now Git will open up our Git text editor again, because we said we want to reword the commit message of the very first commit. And now we will write add a 5th. So this commit will add a 5th, a 6th, and a 7th test. Perfect. Let's close that. So Git has now squashed or kind of fixed up all these 3 commits into a single one, and we can verify that by hitting git log, and there it is. The commit which we took off here at the 4 test, and here is our all new commit at a 5th, a 6th, and a 7th test. So the next thing we can do is to create a pull request again on the remote repository, and for that we will push that branch, git push, and as we already know, we have to set the upstream origin feature branch for that. So git push, we can do that in one go. Set upstream origin, name of the remote repository, then feature dash test 5 Lisa amend. Exactly, we push that to the remote repository, and now we will switch over to the remote repository. So here we are with Lisa on the remote repository manager. We do a refresh. We have here a third branch now, a new branch. This is this feature test 5 Lisa amend, which we have just pushed. So we select that one. We create a new pull request. So what we want to do is to pull, that's why it actually is named pull. We want to pull the feature test 5 Lisa amend branch into the master branch. So we create a new pull request. Here we choose again Jessica as a reviewer, and we leave the rest as it is, and we create a new pull request. Now we switch over to Jessica's account. As Jessica, we do a refresh. We get notified that we have a new task which is assigned to us. This is this test 5 Lisa amend feature branch, which we have to review now. So one file has changed. We can see here, Lisa has added a new test 5, a Lisa test 6, and a Lisa test 7. So this looks pretty good to us, so we will approve that. Once it is approved, Lisa can now merge that into the main master branch. So we head over to Lisa, refresh the page here, and we can see, oh yes, cool, Jessica just approved our pull request. And now we can do a rebase and merge that into the main master branch. Perfect, done! Now we can verify that by going to the project, and now we are on the master branch. We are checking the commits. Here we are, so all the commits on the master branch, and there it is, our add a 5th, a 6th and 7th test commit, which we have just added. We can quickly verify the commit graph. That's the visual representation of our commit history on the master branch, and there we are, all the commits in a nice and shiny order. Now, as we have changed the master branch on the remote repository, we have again to fetch and merge the changes to the local repositories from Jessica and Lisa. So let's do this. First we will update the master branch from Lisa. So here we do a git fetch, then we switch over to the master branch, and now we can already see your branch is behind the remote repository master branch by one commit and can be fast forwarded, which means we just have to hit git merge, and now we merge the changes from the remote repository master branch into our checked out local master branch. Now we head over to Jessica's local repository to do the same there. So as Jessica, we have to do a git fetch. It will fetch all the new data from the remote repository. Then do a git status here, because we are already on the master branch. And we can see your branch is behind the origin master by one commit. So also here all we have to do is do a git merge. And now also Jessica is up to date with her local master branch. Be careful and thoughtful when you intend to go back to the future for rewriting history, either by amending or rebasing interactive on a public shared branch on a remote repository where other people are working on. It might be a good idea to check with the others first what your intention of such a move is. The general advice is don't rewrite the history of the master branch of an open source project, and of course don't rewrite the history of your company's release branch. In most cases, the master branch or main branch of a project is anyway protected against rewriting its history. For example, GitHub offers a number of tools to achieve frictionless collaboration and help you keep your repositories in good shape without littering your development workflow with unnecessary obstructions. Lisa can be proud of herself. She tackled the two tasks with bravery and learned a lot thereby.